Howdy, it's tubalcain again. You know, it's been some time since I've made a project, so today I'm going to start making another one of these STIRLING engines. And even if you're not interested in STIRLING engines, you know, you may like some of the machine work that I do, because this is really a machine shop project. And even if you don't have any interest in the STIRLING type engines, well, you still might find some of this interesting. Now, this is going to be a long video. It's going to take many parts, and I'm going to try to show most of what I'm doing when I'm machining one of these, but I can't show everything. It would just take too long, so we will skip around a little bit. But first, let's watch this engine run. Okay, I'm warming the engine up, and a STIRLING engine runs with any kind of heat here on this hot end. And I'm not going to explain the principles of this, but this is Mammoth solid fuel tablets that I'm using. The S-bit are about the same. The Mammoth's made in England. I think this is German or Swiss. It takes about 2 or 3 minutes to heat up. Then it's ready to run. Now, if you want to know more about this, I got 2 other videos. One's called STIRLING Hot Air Engine tubalcain, and you can just do a search on that. And then if you want to know exactly how they work, look for the principles of STIRLING Hot Air Engines by tubalcain. And finally, I have hundreds and hundreds of videos. If you look up index of tubalcain machine shop videos, you'll find an index of the hundreds of videos that I have. And now it's ready to run. So we'll run it real briefly, and then we'll start talking about machining it. They get pretty hot after a while. Not for children to play with, because it's mighty hot on that end. These are fairly easy to build, but they must be built precisely with good fits, or they are not going to run. Okay. That's enough of that. Let's commence with the machining. These are the 2 main castings, the base and then the cylinder and displacer casting. And this is the one that's kind of complicated. It has many, many different steps in making this. There isn't a whole lot to the base, so we're going to start with that. But first, let me say that I made these castings probably a couple of years ago, but there's the original pattern, the wooden pattern. And if you want to see me make castings, I have some videos of that if you haven't already seen them. Maybe not these particular castings, but the principle is the same. Remember that a foundry pattern is tapered. It's called draft, so that it'll pull out of the sand. And actually, this pattern was made for another engine, but I modified it so that it would fit in the STIRLING principle that I'm going to do here. But the reason for these curves, there used to be 2 flywheels on a little steam engine, and they fit into that curve. And now we're not using that part at all, because the flywheel will go through this slot here. The first thing I'll do is put this on the belt sander and take off the gates. They've already been sawed off from casting, and a little bit of one on the other end, and that's real quick to do. And then the only machining on here is to machine this well out, and we'll do that on the milling machine. And I'm going to mill some flats, one right here and one right here on these upright pieces. And the purpose of that is so that when I drill that cross hole, the drill bit does not deflect a little bit on the taper, because all the parts are tapered, as you can see. So I'm just going to take the taper off right there and right there, so that I can drill and ream through here. So let's step over to the belt sander. This angle is approximately 8 degrees, so I have set the table on the belt sander, the Rockwell belt sander, at that angle. And this part here is machined, so what I do is I just put this up against there and adjust the tilting table until this angle coincides with this surface here. And then we're ready to do our sanding. It just takes a second, and same thing on this end. And that's ready to go. Often there's a little inclusions and bad spots, you know, where the gate went in, but I'm not worried about that. I'll just paint over it, or I could use body filler and fill that, but it's not critical at all. I might take just a little bit more off of this side. I'm at the Bridgeport mill now, and I'm getting ready to mill this out and clean these two parts of the casting like I just showed you. Now, what I did here is I clamped the casting in two different places, you know, once here and once here. But before I did that, I made sure that it was squared up good with the table. And that's not too important. You could even just eyeball that, but using a square is accurate enough. And when holding a casting like this, be careful not, since it's hollow, not to put too much pressure here with your clamps, because you can crack a casting like this. So there won't be a whole lot of pressure with the milling cutter. And then as far as the milling cutter, I've used one with a little bit longer flutes than normal, and have a little more shank sticking out than what I want, because I have to reach down into here to mill this out, and I need clearance from this. So I have to have, so I don't hit the collet right here. So now we're ready to mill. And I might take just a little bit off of here. I don't know how much needs to come off, but I think I'll clean that so I know that it's flat. And I might have to take more off later. I don't remember whether this dimension was correct. I normally wouldn't allow this much of the quill to stick out if I was milling steel, but for the light aluminum that I'm going to mill here now, this could matter less. So we got about 4 inches of quill sticking out. And now I'm ready to get right in here and mill this off, just so that it's, I've taken the pattern draft off, or the casting taper off here and here, and that'll just take 1 or 2 little passes, and the finish doesn't matter either. Now I take fairly light cuts when I mill something like this, because there is the possibility of cracking one of these castings off, then I'd have to start over. Now I'm going to mill out the well for the flywheel. I had made the casting fairly thin right there, so there isn't a lot to mill. Use a brush, don't stick your fingers in there. Wear your safety glasses, I've got mine on. I'm going to widen that just a little more, and then that's all there is to the milling. I'll come back and clean this off just a little bit. Next, I'm milling this surface just enough to clean up the casting. Need a little more depth to it. That's it. I'll take off a few more of the burrs with a file and we're done. Somebody always asks me, do I have castings for sale? No, I do not have castings for sale. Then they say, well, do you have blueprints or drawings? No, I do not work from drawings. When I make the very first one, I have maybe some sketches, maybe some dimensions written down, etc. But most of it's in my head. Now, I haven't made one of these in 5 years, so some of what was in my head is long gone. So I know you're not supposed to do this, and this violates every principle of good machining, but I just take some of the dimensions directly off my other one. So for instance, right now, I have found the center here of this shaft with my height gauge, and I'm just going to transfer that dimension onto the casting. I put some magic marker, works kind of good too. Instead of bluing, it doesn't take so long to dry. So I'll just make a mark here, and then I will find the center this way, and then I'm ready to drill and ream. I do not need to lay it out here because I'm going to drill and ream all the way through, which in some cases I suppose you call line reaming. So I'm going to center punch that very carefully so I don't break this off. I will support this some way when I center punch it, rather than just laying it on the bench and striking it, because that is very likely to break off. You can see now how I have machined that well, and the flywheel sticks through there. This is the very first hole I will have drilled in my new Duro drill press, my new used one. And so I'm going to enjoy that production table now, where I can slide things around and have a little more room to work. Notice how I have set the work up on an angle plate, got a couple clamps on it. It's not going to go anywhere, but I like to hold it on an angle plate rather than a vise, because we know that it's going to be good and square. Also, sometimes if there's no webbing on an angle plate, I like to hold it on the inside because there's no tendency for the angle plate to want to tip over, because I'm not going to clamp this to the drill press table. I'm going to let it float around. I'm going to center drill first, and then 11/64, and then a 3/16 reamer. And I always like to lay out the drills I'm going to use and reamers so I don't have to run for them. And I measure everything. For instance, at 11/64, I did check it with a drill gauge to make sure that it truly is that, so you don't spoil your work. It is most discouraging to ruin a casting or a part that you have some time invested in. So make sure that your drill bits are sharp and that they're the correct size. Now for your safety Nazis, I just rolled up my sleeves and I have my safety glasses on. That's a number 2 center drill in the chuck. And let's get ready to drill. Again, not too much pressure so it would break the casting, because there is no support right now. Right here. You could put jacks under there or some way to hold it, but I'm just taking my time here. And I just go in a little ways with a center drill in order to establish the hole, that the hole is truly where I want it. And now you see why I mill that off, so that the drill bit does not deflect just a little bit because of the taper. It's got a nice flat surface to establish itself. 11/64 drill, and I put some Alumatap on there. And then I'm going to go all the way through and drill it down here. I'm going to take my time letting that drill bit get a good start down there. I dropped the drill press table just a little bit so I had room for a reamer. The reamer is always longer than the drill bit. Then I can float the work around. And there we go. Hopefully we have a hole that's perfectly sized and located and ready to hold the shaft. Alright, I've temporarily installed the flywheel in there. This is 3/16 stainless steel shaft. It's extra long. I'll trim it to length later on. Also, I'll provide a flat for that set screw so that it doesn't come loose. Set screws usually fail in the smaller sizes. The reason I use stainless steel is I have 1,000 feet of it that I got super cheap. That spins nice, there's no binding. You know, I make these flywheels, I might have shown in another video, they are of a hard lead, which is like type lead or wheel weight lead with some antimony in it, in a permanent mold, so I have a bunch of them in stock and I don't have to fiddle around making this, because you can spend a lot of time on a flywheel, and most of my little engines were designed to use the same flywheel, which is about 3.5 or 3.25 diameter. So a bunch of those made up and painted, and they've been sitting there for years. So that's all I'm going to do now for the time being on the base, and we will turn our attention to the main casting. This is the wooden split pattern I used to make the casting. It took an awful lot of time to make something like that, as you can imagine. September '04, wow, I made that, what, 8-9 years ago. Can't believe the time has passed. Anyway, what we have here is a core print. This is the core print. It allowed me to place a core into the sand mold, but in this case my core actually was a steel tube. Now I packed it full of sand temporarily, and the reason for that is in case any metal escaped around the end, you know, we didn't want it to fill the empty core. But this is steel tubing, and it's cast right in there. Now this tubing actually is a broom handle from the dollar store, and you know how thin those things are. So it's a mighty thin material. This is extra long. It's going to be trimmed here and faced. That's the first thing I will do. And then later on I'll determine the length, cut this off, and silver solder a cap on it. Now in some of these that I have made, I cast the hole right in here. Now I did not do that into this one, and I don't remember why. So this was the core print for that. But that was a difficult core to make because it was so long and slender and it was delicate, so that's probably why I got away from that. Here's a boss, and in that boss we will drill a hole all the way from this side up into this part right here. Now this is the displacer side, this is the piston side, or the power piston side. They are not the same. This is a displacer. Talk more about that later on, or look at my other video to learn more about that. But to start with, I'm going to put this into the closing lathe and face this end off. Now I don't want to damage this and have this collapse into the casting, so I'm going to remove some of that fairly close down to the casting and then machine this off. I don't want to use a hacksaw, because a hacksaw on a thin tubing like this may cause it to collapse or pinch a little bit. I don't want that to happen, so I think I'll probably use my little Dremel tool with an abrasive wheel. I'm getting ready to use my little Ryobi grinder, and I just had to change wheels on it. Make sure that you wear safety goggles when you use these, but there is quite an assortment of cutoff wheels, and generally I use just the standard ones, which is like that, and they make those in two thicknesses. The number 409s and the 420s, which are the thick ones, the heavy duty they call them. Lately I've been on the kick of using these reinforced Dremel wheels, and I just had to change it because that's the old one and it wore down to, there's not much left. They last a long time, but they have that cloth in them or whatever it is, and these are real nice. That's what I'm going to use here to cut the tubing here presently. Yeah, it doesn't take too much to cut through that, so I'll cut that all the way around, but I'll have to reposition it at least once in the vise. And then this gate here, I will use my nice heavy-duty double cut file and knock most of that off. Then I'll take it over to the belt sander, or I might use this little belt sander right here and sand that so it's smooth as I rotate it. I have rough cut the tubing off, as just shown, and then I sanded this down so it's smooth as a hound's tooth. And when I design my projects and castings and so on, I try to design them such that there's a way to hold them in the chuck. Quite often you make something and it just defies being held. So this is set up so I can hold it by the chuck in order to do the drilling and boring in here, but right now I can hold it by this and face off the end. So I'm going to put it into the 3-jaw, just like that, and it goes all the way up against the face of the jaw, and I kind of center that and make sure that it's going to be all right. Snug her up, rotate it, and it's ready to machine. Now I'm using this long nose snout here on my Aloris tool holder, almost like a boring bar, so that this piece that swings around will not strike anything. So always rotate your work by hand to make sure it's going to clear everything. And now I'm ready to machine this. All I'm going to do is face it off clean. There's no particular dimension, and I'm going to feed from the center out, so I do not tend to tear the steel that's in there. I don't want that to collapse a little bit. Just feeding by hand. I'm not using power feed. Now I'm going to stick the burr knife in there, back the tool out, stick the burr knife in there and take the little burr out of there. Now when you turn something like this, if it was steel, more than likely this would vibrate and it would be out of balance, but since it's aluminum, there It doesn't seem to be any out of balance that I'm noticing with this heavy clawsing lathe. You might notice it more on a light lathe, but the heavier a lathe is, the better it is able to absorb vibration. This is the clawsing 12-inch, my favorite lathe. Okay, that looks good. I deburred that while I was on the lathe. Now this is welded tubing, so there's a seam. And I may need to Dremel that out just a little bit so that when I go to put my end cap in, it doesn't interfere with that. But the reason I took such care to face that rather than sand it is that I want this surface here to be perfectly perpendicular with the center line of the displacer tube. And that will assure that. And now this piece has to be made to fit on there. This is oversized because I've used that on many different models. So universal, I just machine it down to the correct size. I'm going into a lot of detail in this video because some people want the detail. If it's annoying, just speed up a little bit during some of these segments because this can be a very, very long video. Now I see I got a mark here. I believe that originally I put that mark on there because I need to machine it off to that point. Same thing with that groove. I believe that, yeah, that's going to be machined off to that point. Normally I have a couple little holes here. You can still see the scribe mark of where I want to drill these two holes. But it looks like it was lost in translation there, so I'm going to have to relay those out, and I'm going to drill two holes for what I believe are number 8 screws.